So we've taken a sample of gasoline prices and we figured out that the average for gasoline price in the whole state will fall within this range. And so we're asked to find the sample mean and the maximum margin of error. Well, the way we find this range is we take our sample mean and we subtract the margin of error to get the lower number, and we take that sample mean and add the margin of error to get the bigger number. So the sample mean's right in the middle of our range, and then the margin of error, we subtract it to the lower one and add it to get the bigger one. So to see that, so to find the middle of this range of prices, the sample mean is going to be right in the middle. Take the range, which is 30 cents, from 315 to 345 is 30 cents, and just divide it in half. You get 15 cents. So if you add 15 cents, you're going to get the sample mean, which is going to be 330. You could also subtract 15 cents from the larger number, and you get the sample mean, which is 330. And when we divided by 2, we found that 15, that number which we found there was the maximum margin of error, the uppercase E. So E equals 15 cents. And so we took our sample mean and we added our maximum margin of error E to get the upper bound, and we subtracted it to get the lower bound of our range. And we're pretty confident, the problem says 95% confident, that the real average price of gas is somewhere in this range of 315 to 345. Two things to do for number 4. We have to find a 90% and a 99% confidence interval for the information given. So if you look at page 342, it explains how to find the confidence interval for our population mean when we know the population standard deviation. And that was told us in problem 4. It's $250. It says right in the problem. So we're going to try to find this range, which is going to be our sample mean minus and maximum margin of error, and then our sample mean plus the maximum margin of error. And it says right here how to find the maximum margin of error. And so to use that formula, first we need to know what ZC is. And the first part of the problem tells us to find a 90% confidence level. And so if you look at page 340, it's got a convenient table for you to refer to. For a 90% confidence level, our critical value ZC is 1.645. So we're going to plug 1.645 into the formula right here and figure out what E is. So here's our formula, 1.645 times our population standard deviation told us in the problem, and then divide by the square root of how large our sample was, which was 370 insurance claims that we used in our sample. And you get 21.3799 for your maximum margin of error. So you take your sample mean, and to get the confidence interval, you're going to subtract that maximum margin of error to get this number, and add it to get this number. So we are 90% confident that the real average price of an auto claim is within this range of numbers. And the second part of the problem says to find a 99% confidence interval. Going to go about it in the same way, but just refer back to page 340. For a 99% confidence level, you need to use the number 2.58 for your critical value. And so you change your critical value, you'll get 33.532 for your maximum margin of error, which produces the confidence interval from 1536 up to 1603. So you can see that to be more confident, to be 99% confident, you had to have a larger range of numbers, and that should make sense. This range of numbers is bigger than this range. Here we were only 90% confident, and here we're 99% confident. If you include more numbers in your possibilities, you have a better chance of the real mean, the population mean, being in your range of numbers. If you include less numbers, the chances are a little bit less that the mean's actually in your range of numbers. For number 6, you have to refer back to number 5. And we're trying to figure out how big a sample we need to take to be 99% confident, and also within 2 points of the population mean. And reading through number 5 here, we know the population standard deviation is 7.81. And since we know the population standard deviation, look at page 345. It gives us the steps for how to find the sample size needed to estimate the population mean. So we're going to need to do this formula right here. We need to look up a critical value. Now the problem said we want to be 99% confident. Again, refer to page 340. For 99% confidence, your critical value should be 2.58. So we're going to plug 2.58 into this formula. And I just use Excel again. You can use any calculator, but you do 2.58, the critical value, multiplied by the population standard deviation, which is told to us in number 5, and divide by your maximum margin of error. And the problem says we want that to be only 2. We want to be within 2 points of the actual population mean. Put those numbers in and then square the result, and we get 101.504. Now, our sample needs to be a whole number here. We can't have half of a person. So to be conservative, round up. If we have a sample of at least 102 people, we'll be 99% confident that whatever our sample mean is, it'll be within 2 of the actual mean, the actual population mean. So 102 is the sample size we need. The first part of number 8 is just to verify what the mean, the sample mean, and sample standard deviation are of these numbers. You can just use Excel and type in the 10 numbers. For the mean, use the average formula. You get 15.78. And they're going to round that to 15.8 in the problem. So yes, we verified the mean's 15.8. And the standard deviation, make sure you use the formula for a sample standard deviation, because we just have a sample of 10 items here. If you use the population with a P, you get the wrong number. And so this, yes, like they say in the problem, it's approximately 3.5 if you round that for the sample standard deviation. So for part B, we need to find an 80% confidence interval for the population mean. But we don't know the population standard deviation. So we have to go to 8.2, and we're going to use the student's t distribution. So on the bottom of page 353, it talks about how to find a confidence interval for the population mean when the population standard deviation is unknown. And since that was not told to us in the problem, we have to use this formula. It's pretty similar, but our maximum error of estimation is going to require this formula. So we need to look up TC, our critical value here, using the student's t distribution. So let's go to table 4 of the appendix. So table 4 is on page A10 at the back, and our problem wanted us to have an 80% confidence interval. So on the headers here, find 80%, and then you need to go down to the correct degrees of freedom. And if you remember from reading in 8.2, the degrees of freedom is 1 less than the size of your sample. And we had 10 in our sample, so our degrees of freedom is going to be 9. So we're going to use 1.383 for our critical value. So we're going to plug 1.383 in here for our critical value, along with our other information. So jumping back into Excel to find our maximum margin of error, I am plugging in our critical value, multiplying by our sample standard deviation, which we verified was 3.5, and dividing by the square root of 10. And I'm using 10 because that's the size of our sample. We had 10 things in our sample. So the square root of your sample size. You get 1.5307. So what we're doing is taking our sample mean which we verified was 15.8, subtract our maximum margin of error, and also add our maximum margin of error, and that gives us this range of numbers. And we are 80% confident that the real population mean will fall within this range of numbers.